Hey, welcome back to another Firecast about cloud functions for Firebase. My name is Doug Stevenson, and today's topic is programming with JavaScript promises and a Firestore trigger on cloud functions. In the last video, I talked about using promises in an HTTP trigger. If you haven't watched that video, do it first, and come back here when you're done. I'll wait. So you learned last time that a JavaScript promise represents some asynchronous work going on in the background of your function. It has three states: pending, fulfilled, and rejected. And you can write callbacks using the then and catch methods on a promise to know when the state changes. You also learned the first rule for terminating a cloud function. HTTP triggers must send a response to the client to terminate properly. Today we'll look at the second rule. For all other types of triggers, you must return a promise that becomes fulfilled or rejected when all the pending work in that function is complete. This lets cloud functions know when it's safe to clean up the function invocation and move on to the next one. Last time, I wrote an HTTP function that fetches a document from Firestore, and it sends its contents to the client like a simple web API. This time, I'm going to write a Firestore trigger that fires whenever that document gets updated with new data. If you recall, my Firestore database looks like this. In the Firebase console, you can see I have a collection called Cities Weather, where each document tracks the weather conditions over time in a city. As I mentioned in the last video, I'm going to Boston soon, so I made an HTTP API endpoint that my app can call to get the latest conditions. Any app can poll this location to check for updates to see if something changed with the weather conditions in Boston. This is okay for general use by anyone who knows the HTTP endpoint, but I have my own Firebase app connected to this project, and I don't want my app to keep polling this endpoint repeatedly to get updates. There's a better way to do this. What I want to do instead of polling is write a Firestore trigger that fires in response to updates in the Boston weather document. With each update, I'll use cloud messaging to send a notification to my app to indicate a change in weather conditions. This is far more efficient than repeatedly polling the HTTP endpoint or even querying the document directly, and my app can always stay up to date with the latest weather data, even when it's not running. Let's see how to do that. Here's the HTTP function from last time that can be polled for weather updates in Boston. What I'll do here is write a new Firestore trigger that fires in response to updates to that document. I'll export it and call it onBostonWeatherUpdate. Then I'll use the functions SDK to create a Firestore trigger that responds to updates in the Boston weather document. I'll pass a function to the onUpdate method, which will be invoked whenever there's a change in this document. The function accepts a change parameter that describes the update that happened. The change parameter has two properties: before and after. I'm interested in the contents of the document after the change occurred. This after property is a document snapshot with the updated contents of that document, so I'll use its data method to convert it to a JavaScript object. Now that I have the document data, what I want to do is build an FCM message payload to send to my app. I'll paste some code here that I already wrote. FCM requires all the values to be strings, so I'm converting any numbers to strings as needed. Now I'll use the admin SDK to send this data payload to a topic called weather_Boston. This lets every installation of my app receive these notifications if it uses the FCM SDK to subscribe to this topic. If you're not familiar with FCM, that's okay. You can learn all about that by clicking the links in the description below. It's a great way to keep your app up to date with changes in your database. But there's one thing I forgot in my code. Remember the second rule for terminating all functions other than HTTP triggers. They must return a promise that's fulfilled or rejected when all the pending work is complete. What I forgot to check in my code is what the admin SDK returns when I sent that message. So let's go see it in VS Code. If I hover the mouse over Send to Topic, VS Code will tell me its arguments and return value. And I can see here that it returns a promise. That means this function returns immediately, but it isn't finished until the promise is fulfilled or rejected. So what I can do here is return this promise from my function, and that will make cloud functions wait until FCM is done before cleaning up and moving on. Okay, that's better. But there's still one thing to consider. Remember that every promise either becomes fulfilled successfully or rejected with an error. So it's a good idea to think about if you need to handle any error conditions when you're dealing with the promise. If you remember from the last video, you can use the catch method on a promise to trap any errors. What I'll do is call the catch method on the promise returned by sendToTopic. I'll pass it a callback function that handles the error condition. For now, I'll just log it. And also note the catch itself returns a promise when its callback is complete, which is what this entire function is actually returning now. But if all you're going to do is log the error, there's no reason to use catch here. If I just return the original promise as before, Cloud Functions will log the error if the promise is rejected. In that function, if I didn't return a promise that's fulfilled when the admin SDK is done sending the message asynchronously, it's very possible that the message would never be sent because Cloud Functions could clean up before the work is done. Forgetting to return a promise can lead to inconsistent bugs in your background function. You should always track the promises returned by APIs you call in your functions. That way, you always return a promise from your background function. This includes functions triggered not only for changes in Firestore, but also in real-time database, cloud storage, authentication, analytics, Crashlytics, and PubSub, and possibly more to come. You should know there's still more to learn about promises. Next time, I'll talk about what you can do with promises to manage more complicated work in your function code. So, subscribe here to the Firebase channel on YouTube to get notified of that. Until then, check out some of the links in the documentation in the description below, and I'll see you here next time.